Hey everyone. Okay, well, first, just a couple of things. I wanted to thank everyone who attended the Halloween stream. It was my most successful math stream to date. And now I am going to continue. My goal right now is to finish chapter 1.2. So we did section A. I want to finish section B. As usual, I'm going to quickly go over how this works. We are doing the Book of Proof by Richard Hammock. If you want to download it, it's open. It's Creative Commons, and the link is in the video description. So you can go and download it or buy it. Like, it's a very nice copy. And then what will happen is I am a student. This is a class I did not pass, so I'm studying for my own benefit, and anyone else that helps is great. So a couple of real things I'm going to do here. Set up my banners. So what happens is if you want to affect the stream, because this is an IRL type stream, you can do a Venmo donation with your message, and I have to display it. Although I do react to other messages. And the other thing I'm going to do, I'm going to explain real quick, is that um, do not assume that I'm going to get everything right. I don't have, this is not like where I have prepared answers. I'm simply doing homework. I'm doing the odd questions, so that way I don't undermine the integrity of the book. By doing the odds, if I show you how it's done correctly, we could quickly verify it by checking at the back of the book. And as a matter of fact, if you downloaded the book, you can actually already know the answer before I even get to it. So that's a fun thing you can do too. Anyway, let's get into it. See here. I'm a little hoarse, been working a lot. So this is close to my bedtime, but I did want to do some math. All right, well, I want to check my stream, make sure that I'm actually presenting as I think I am. All right, let's see if I can just hear myself. That's all I really care about. Okay, yeah, it's good. All right, so now I'm going to mute myself. And quick greeting message to anyone watching. All right, let's get into it. All right. Just gonna sort my stuff around a little bit. I have a little bit too much stuff. Okay. Now, all right. In terms of where we're at, we are still on page 11, and this is, we are doing B. We did A last time, so let's write this in here. Let's try layers. First layer, we're going to say okay, sounds good. All right, it's going to add another layer, and I'm not displaying it. All right, let's fix that real quick. There we go. Okay, there we go. So I'm glad I checked on that real quick. So we are sketching Cartesian products on the XY plane in R2 or R3. For those who watch the Halloween stream, I did do the last question, did it correctly. So you already know what's coming. I just wanted to have a crack at that because it's in R3, so it's three-dimensional space. We're going to start with some R2s though. All right. 9. Set 1, 2, 3. by -1, 0, 1. Okay, so we are going to create Cartesian products. So just like before, this is, say, A times B. We're going to go A1, A2, A3, like that. And then this, since this is an R2, let's gonna mark this right here. This is R2. That's two-dimensional space. That means X, Y plane. So that's what we're doing. We're graphing in the XY plane, also known as R2, two-dimensional space. All right. Well, let's do our product. So we're just gonna write our sets. So we're gonna multiply A1 by B1. So that's gonna be 1, -1. Okay. Also, when you do it like this, the first number here, that's considered the x-axis. The second one, this one, is considered the y-axis. If you're doing R3, the third one will be the z-axis. Okay, and stick around to the last question, then I'll show you how that looks like. Okay, so now we have, so A1 times B1, and then A1, B2. Now the order, and this is something that got hung up on last time, was because the book was sometimes giving different orders. It doesn't really matter for this kind of a question, because as long as my sets are correct, we're gonna have the correct order. Because look, if we did B times A, that means, for example, if we did B times A, just gonna take the red pen. If we did B times A, then what would happen is we would say, then in that case, I actually wrote this wrong. This is still B. If we did B times A, then the first set would be like this. It would be -1 and 1. Now, that right there, this is not the same as A times B, because this is now the x-axis gives us -1 instead of 1, right? It flips it around. So what we would graph would be different. We don't want that. So that, in regards to the thing that I was tearing my hair out, as you can see, I got none left, was that this is how you can tell. I said that if I can't figure it out eventually, whether the ordering is important or not, look, whether I write this set inside here, I can also write this, right? That's fine. Okay, the ordering in here is fine, because what will happen is that I'm still going to graph them the same way. This is still XY, and just as this is XY. That's what matters. Here we go, XY. So that's all that matters. Now, I'm going to take all that out. I should just create a new layer next time. Anyway, let's just continue doing this. So we have A1. Just correct my seat here. Comfort. Okay. Yeah, we have A1, B1, A1, B2, A1, B3. All right. A2, B1. Okay. A2, B2. A2, B3. Okay. And then we're going to have, see here, A3, B1, A3, B2, A3, B3. All right. All righty. So far, so good. And let me just check on this here. Perfect. Okay, good. So now we know, like I said, the first is X, the second one's Y. So this is of the XY form. And then all we got to do is, one other thing I haven't mentioned. Right. So parentheses versus square brackets, right? So this will still give us the same thing. However, parenthesis, let's just do it in R1 for a second. If we do R1, or just R, this is the same thing. Here we go. So for instance, if we had to say something like this, this would refer to a range. So if we have, let's say, -1 and 1, so that would be the equivalent of saying, say 0. See, this is -1 and 1 and 1, and this goes on for infinity. This would be open, open, and then this would be closed. That's the range. If it was square brackets, in that case, if it was square brackets, then we would say, let's say -1 and 1, square brackets, and that's the equivalent to saying this. Okay, -1. That would be closed range, okay? So that's how we see it in R or R1. Now, if what you want to keep in mind is that we have to, if it's a two-dimensional plane, that means that we would occupy the entire area. But right now, because these are all open, what we're going to do is we're going to use dashes on the border because the border is not occupied. Anyway, if I get this wrong, we're going to know pretty quick, but I should be correct in what I'm saying here. All right, so this is our y-axis, this is our x-axis. So now we could, we could say this goes to say like 100 or whatever, but then, if this was like 10, we'd be operating in this tiny area, right? We don't want that. So if you're gonna plot your range, we don't really need to go much higher than what we currently have here. So our highest number, our positive numbers, we range from 3. So we could say like 4, or like, or even just we could say, yeah, maybe 4. We're going to go 4 notches. 1, 2, 3, 4. 1 past the highest we have. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It's just for our visual sake so we can have an easier time of seeing what goes where. All right. Let's start plotting them. We have x goes to 1, and then y is -1. Okay, so that's going to be right here. We're just going to draw a circle there. Okay, next one. We have x is 1, y is 0. Okay, we'll just put a circle there. All right, and then we have 1 and 1, x1, y1. Okay, all right, so then we have x2, 1, 2, and then y1. All right, okay, and then we have, wait a minute, x2, y -1. Sorry, down here. Okay, and then x2 and y is gonna be 0. Okay, all right, and then x2, y is 1. All right, okay, and then x3 is right here. Hang on a minute. Yeah, 3 -1, 3, 0, 3, 1. Okay. So this is where I'm probably gonna screw it up. And so the the marks are correct in terms of the location, but how I interpreted it, this is where I'm probably gonna get it wrong, because it's not immediately clear to me what the shape of it should be. But once I see the answer, I'm gonna say, okay, yeah. Um, well, let's see. Before I do that, um, let me go back and read the question one more time. And this is in the range R. Okay, that wasn't anything. So now it doesn't tell me specifically what. So presumably it's the real set. So any number should occupy. I could interpret this thing as being a box. I suppose we can say it would be something like this. If we just say dashes, something like that. Now the dots, doesn't matter. There, you can write them as dashes. The dots can also be dashed, but they're not filled in. So essentially, we have a border that goes like this between them. So let me see what that looks like. All right. Right. And sketch the Cartesian products. Okay. No, I screwed it up. and I'm going to tell you why I screwed it up. I can immediately see what I did wrong. Okay. So the correct answer, this is the correct one. Let's see here. 1, 2, 3. See here, and then 1, 1. Okay, it's like this. And I am going to explain why I got this wrong, because now it makes total sense. All right. So remember what I said about closed and open brackets? The problem was that is right here. This is where I messed up. As you can see, it doesn't specify them. These are just whole numbers that exist as, so basically whenever you have curly braces, that means you got a box. Just think box, okay? Curly braces equals box. Inside this box, anything separated by comma is an item. In this case, since we're dealing with Cartesian products, these are whole numbers in this case, and the coordinates we're using, because they are whole, each one is it occupies that space. -1 is its. What I should have done is I should have actually written it like this. I should have written this out as, at least that's how I probably would think I should have done it. Because now doesn't now again, this is the kind of thing is like, I could be screwing this up. You could keep it open braces, I suppose, but you have to be extremely careful by specifying the range, or if you're saying naturals. Let me see here. But for another example, I'm just looking at a few examples here. This is Cartesian products. So we don't. Okay. That's one way of interpreting it. But the book itself is not against the way I wrote it in terms of keeping them in braces. The problem was that I basically, well, you just have to kind of carry it mentally what you're looking at. So this, in this case, if it had been specific like this, if it was specific like that, then you would have had to know which was open or closed. But because the book didn't go like that, but simply went like this, a minor difference, but it's enough to say what you're actually looking at. This is open braces. This is simply items. So these are like these are like tiny little things, but they make huge difference in math. Anyway, so this is the correct answer right here. And as you could see, my answer was a little off, but we learn. So that's how it works. It's important. Okay, let's move on. All right. We're gonna. Whoa! Look at that. How cool is that? I'm getting better at this. All right. Now. All right. Hmm. Right. Okay. Still in section 1.2b. That was 9. We answered that. 11 is now we're gonna do. This is 11. All right. So let's just ground rules. Let's just go over it one more time. Okay. This right here, this is set brackets, right? That means anything in there is an item. Like I was saying the other day, you could have a list of books. Like it could be letters, it could be numbers, it could be Greeks, it could be anything you want it. So these are set brackets. This right here, this refers to, for because we're graphing, especially if it's like XY or XYZ, the ordering, these are ordered pairs, and those, the type of the brackets for these two, these are open. Closed. Okay, so you got to remember that. Okay, that little mistake is what I made and I screwed up. Although like I did the at least part of it was correct. Now the other thing you should keep in mind is that like my mistake, while it didn't graph it correctly, the sets that I printed out was correct. So I probably would have gotten partial credit had I submitted it like that. But keep that in mind. This is because I'm still in school. In real life, you don't get partial credit for failure. If a satellite falls out of the sky, there's no partial credit there. You gotta know your math right. This is why I'm doing this. I do this for my own benefit because I need to learn this. And plus, I enjoy it. You really look. If you hate something, if it find it boring, find yourself. You got to do something else. If you don't enjoy what you do, you're gonna absolutely hate it when you graduate. Just keep that in mind. Okay, so again, this is gonna be in R2. And how do I know this? Well, there's only two. There's X, Y, right? There's no three. We wouldn't graph R4 because um a okay, so we know three space, right? That's the world we live in. Four space would, well, mathematically you can definitely do that, but essentially you have another plane of existence that is parallel to the other one, or I wouldn't say parallel. It would intersect in a way that would make it very hard to graph visually. I mean, I suppose some people could probably graph four space, but essentially, so R1, or which is equals to R, is just a number line. Okay. R2, we now have XY, and R3, so we have, this is hard. Okay, so, and you could also continue this way. If you wanted this way, you can go like that. So, and this is our space. So this is X, Y, a minute. No, that's incorrect. Y, Z. Okay. So that's how you would do it. And I suppose if you were to go into R4, well, again, you could. I'm guessing. I haven't graphed R4 ever. I would imagine you could run it through here, but then it just becomes increasingly complicated how this whole thing would work and what shape it would take. I don't know. This is probably incorrect, but it's one of those things. You do a lot of it in linear algebra. There's the R space that you can operate in. I mean, you can have 7, 8, whatever, and you talk about the span and whatnot, and you're not even trying to visualize it. You're simply doing the math. Linear algebra is fun. It's another class that I didn't pass. I dropped to focus on my landscaping / handyman business, which I'll get into some linear algebra eventually. Yeah, for my own practice. But let's get back to ordering some pairs. Okay, so here's the thing. Look, they're not putting curly braces around it, right? This is just an ordered pair, and so we're just gonna multiply. We're still using the A times B methods that we've A times B. We're still using that. So ordering the pair, we're gonna go 0, 0. And we can put set brackets because as we're understanding is we're creating a new set. Obviously, any items that we put in here, it's like, okay, well, we can just put a box around it, but for our purposes it doesn't really matter because I'm just, for neatness sake, I'm just gonna organize them in a set. And technically you probably should do that anyway, but here we go. A1 times B1 is 0, 0. A1 times B2, 0, 1. A2 times B1. A2 times B2. All right. All right. Okay, so we have 0, 0. By the way, because, well, okay, but let's be consistent about it. Since I am ordering square brackets, they should all be closed. So we're just going to be consistent about how I order. All right. So now 0, 0, first one. Okay, then there's going to be 0. And we're going to say, I'm just going to make it a little wider to make it even wider. Let's go really wide. This is going to be 1. Okay, so this is 1, minus 1, 1, minus 1. Okay, so now, and this is 0. We got our first point, 0, 0. Next one is 0x, y is 1. So 0x, y is 1. All right. Third point, x is 1, y is 0. And final, x is 1, y is 1. Okay. And let's just draw further arrows. So x, y. So this is a box. And we're just going to shade in this box. Or let's not do that. Why would we do that to the box? We have a paint tool. All right, let's just drop some paint in here. There. Voila. Okay, not bad, huh? All right. I'm just gonna fix this so it doesn't look so decrepit. All right. I think that's pretty good. And let's see what the book says. Yeah, the book agrees. Good stuff. All right. All right, and we're gonna turn this one off. Okay, cool. Doing good, doing good. All right, so now, let me check on something real quick here. Here we go. All right. All right, good. So now section, here we go, 13. All right, so these are items. We're just gonna, if it's, well, first let's just write this out. We have 1.5, 2 times, comma 2. Okay. All right, well, let's just do math. So right here, this is a little complicated, but essentially we have whole items on the one side and we have a whole ordered pair on the other. Let's see what that looks like. We're going to order them. All right, and we're going to go X. We're going to say A times B, A1, B1, A1, B2, A2, B1, A2, A2, B2, okay, A3, B1, A3, B2. All right, and it should be 6 items because the first contains 3 items, the second contains 2. So in order to get the size of it, the cardinality, we multiply 3 times 2, which is 6. The cardinality is 6. Okay. Okay, good. All right. So now, if you look at it, at first, it was weird. It's like, I don't know if this is going to work or not, right? It's just a little weird. But we look at it. Yeah, no, it's fine. We were able to get ordered pairs. So regardless of how many are in each set, as long as you can order the pair in XY format or XYZ, then you can graph them. Now remember, XY is R2, so we're sticking to R2. Okay, XY. Now, and then we're just gonna go in order. Let's go. See here. This is 0. We're gonna range between 1. It's a 2. Okay, good. So we're going to range between 1 and 2. So let's do this. We're going to say, whenever you have small numbers, like really small numbers, we're going to use large. We're basically zooming in, so we don't have the issue of like trying to squint and see what we're doing here. Okay, good. So far, I think we got this. Now, let's start graphing. We have 1 and 1. All right. So that's going to be right here. We have closed brackets. We're just going to put a dot. Next, 1 and 2. X1, Y2. It's good to tell yourself what you're doing. X 1.5, Y1. X 1.5, Y1. Okay. Okay, X 1.5, Y2. All right. Good. X2, Y1. X2, Y1. X2, Y2. All right. So remember how in the previous time I screwed this up and then I went with open on the dots? Okay, I'm probably gonna screw this up again, but for a different reason. So hey, progress. So right now we're gonna stick with, I'm gonna take a conservative approach, and I'm gonna assume that these are an ordered pair, and the other thing is I'm gonna say that, hold on. What can we say about them that, let me just think about this for a second here. When this is R, okay. R times N, let's see here. Okay. Okay, this is R times N. Which one is R though? I guess this isn't real, but it doesn't matter here. Be mindful of parentheses. There's a slight difference between R times N times. Yep. Okay. Mm-hmm. Hold on. Let's go back for a second here. Okay, so I'm just going to look for a second at the previous one that I did right, and we're going to use it as a reference here for a minute. So we made ordered pairs, and then it would turn out to be a bunch of dots. Because this was two sets, they were whole numbers. The question is, will the range affect it? All right, I'm just going to stick with same principle here. I'm just going to leave them as it is, and we're going to see what the book says. Okay. No, I got this one wrong again. But for a different reason. So I'm going to see why. The range. Okay. This was between, yeah. Okay, so let me think about this for a minute. This is good that it's a good challenge. All right. But why would it go ranges? Okay. Right. Okay. These are distinct numbers. They're like this, right? Each of there you go. This is an object, this is an object, this is an object. And this is a range. That's what we're doing. We're multiplying objects by ranges. And that has to do with the curly braces. If you just have numbers just floating around inside a curly brace, just items in the box, toys in your toy box, then we have three toys in there, or three little dots, or marbles. And over here, the second one, because it says curly braces, it says the range. So remember, if the first set says nothing about it, just says that's a distinct object. The second one refers to ranges because it goes from, and remember, this is not x y. These are still, this is in this case, we're recreating this as these both end up as y's. That's a y, and that's a down here is a y. So what happens is, what I should have done is should have realized we have a bounded region, and then the range is between 1 and 2. So this was the correct way to answer this. Okay? So now we know the correct answer. Again, I probably would have gotten partial credit for it, at least for getting this part right. Okay. All right, let's turn this off and go to the next one. All right. Yeah, the further you go, the harder it's going to get just to knock these out of the ballpark. When they start introducing a new concept, initially it's going to be easy because they have to keep it simple. But then when they start, remixing them and making you do different stuff, it gets hard. You make a lot of mistakes, but that's how you learn. A lot of stumbling involved in math. All right, but math also guides you out. You can't be perpetually wrong, otherwise your math will not work. And I'm just gonna talk about this for a second. All right, just take a minute before I continue this question. I want to talk about something very interesting, what I like about math, which is pretty amazing. Okay, so here's the thing. Like, there's a type of problem that you could encounter where this is called like crank magnetism, or like this idea that you can, like, let me put it this way. Certain types of people, and I myself, the reason I'm talking about this is something that I would fall into as a uh I could potentially fall for this pitfall. And essentially you have a person that was successful in something that's unrelated to some other field, right? In my case, let's say I was successful as a competitive skater, or successful as running a landscaping business. Anyway, so this person, in this case, again, I'm at risk, and part of the risk group, so to speak, is that they think, well, I have developed certain things that made for me to work for me in life, and because of those principles, I could just apply them anywhere. And then sometimes they can in relatively similar things, but other things they say, well, what if I apply it to something that's highly technical, right? And then because of the Dunning-Kruger effect, this person goes in there and starts thinking that they learn a few things, but the thing with the Dunning-Kruger effect is the less you know, the more you think you know, because you just don't know the width of what you don't know, right? You see the superficial, and you just have no idea just how deep it goes. And then you go in there in something that's highly technical, like math, for example, or science, astronomy, this individual could say, well, none of this makes sense. And then they think, well, maybe I'm just going to be the wild outsider, and I'm going to solve all of the mysteries. And oftentimes, this kind of a thinking, like, I'll give you my own example. When I first took this course, this specific book, right? Um, the teacher challenged us to solve a problem that's, he just introduced this as a fun idea, but it had to do with the prime, the how can you tell if it's a prime number? And essentially, a prime number is a number that's divisible by one in itself. One is not a prime number, and that has to do with the fact that if one was a prime number, then it would just throw off the whole system. In other words, If you have a number that can be divided by two primes, it's not prime. It's a composite number. So, for instance, two is prime, three is prime, six is not prime. If one was prime, then the whole ordering of primes wouldn't work because every number would be divisible by two primes if one being prime. But anyway, so that's how you can tell what a prime number is. It's divisible by one in itself. It starts at two, and there's different methods to figuring out. Essentially, I mean, like for instance, on the small numbers, it's relatively easy. You can just say, well, okay, is six divisible by two? Yes. Okay, so six is out. Let's go to seven. Seven divisible by two? No. Three? No. Four? No. Five? No. Six? No. Seven? Yes. So you have one and seven. Seven is prime, and you can kind of work that way, but it's incredibly ineffective. It's just time consuming. What I'm trying to say is this. So my first instinct, he challenged us to solve to figure out the pattern of the primes, or there's certain conjectures that you can work on. Anyway, and then I was like, well, I can figure this out, and then I started just starting in my own time when I didn't even have time for this, started trying to graph and come up with various fancy patterns and stuff, just laying out numbers and trying to draw spirals through them and whatnot. And then, I showed it to my teacher. He's like, "Yeah, okay, okay." But the thing is, like, right, it's basically it's not that I wasn't answering the question. I wasn't even speaking in the right language, right? It's just like what I was doing is not even wrong in the sense that I wasn't even answering in a way that would have could be wrong, so to speak. It was just so not even correct, which is fine because I'm a beginner. But in retrospect, I understood that to avoid becoming a crank, if you're just doing it because you're like, oh, I want to solve something that's very complicated so that I can get the fame and glory and be remembered forever or the riches, that's the wrong reason, and you won't succeed. Realistically, the people that do this stuff aren't because they're super smart. They're people that actually accomplish things, spend inordinate amount of times of their lives working on it, and usually work as part of very large teams. So unless they're like super large, but the point is, it's a collaborative effort. There's a research going on all the time, and essentially, if you don't want to become a nut, a crank, you want to first of all enjoy what you're doing. Like I enjoy math, and I've learned a lot, and also it humbles you. Like if you can't get through a textbook, right? Don't try to come up with a new scientific theory. And if you do come up with a new scientific theory, does your math work? That's the first question you should ask yourself. Anything that's sciencey, does your math actually work? And it has to work by like not just like in your own head, but you give it to a mathematician or a physicist and they can make the math work, right? Because the other type of crank that exists is, well, you just don't understand my system, right? So don't become that. And like I said, I talk about this because I am part of the risk group in a sense, someone that was successful in a completely unrelated field that starts up a new field and they're used to having a certain amount of success that goes with it. But no, you start from ground zero. Yeah, you take certain principles of hard work and determination, dedication, but really you have to put in the work and you have to enjoy doing the work. So, like I said, for me, I'm not trying to accomplish anything beyond simply learning math and having fun with it. So that was an aside. Now let's get back to solving some questions. All right. Again, we're not doing this to be famous or popular or whatever. Just doing this because I am a student and I like this and it's fun. All right. So, continuing on from where I left off 5 minutes ago. All right. We got through 13. Let's do 15. All right. So, that mistake I made previously, we're going to remember that and apply it correctly here. Let's try that. Okay. So, remember, this is a distinct object. It's a set. We can always do this. We can say that's a set too. But in this case, this is going to be a range. Because this is closed brackets, that means it's a closed range. And we're doing A times B. So, and that's Cartesian products. So what we're doing is we're making an ordered set. A is 1 and B is 0. And then A is 1, B is 1. Okay, and I did not draw the braces correct. Okay, square brackets. Okay, there we go. So remember, curly squares and parentheses, they all mean different things. Okay, so now all we know is this. In this case, just remember this. We're just going to remember this. And remember, this goes to here, and it goes to here. Those are where they are at. And that ends up being the range. So when we graph this, we're going to say, so this is going to be, let's see if I can draw a little better. X, Y. Okay. So we're going to say between 1, 1, 1. Okay. So we're going to say this is 1 minus 1 minus 1, 1. Okay. First one is X is 1, Y 0. Okay. Second one is X is 1, Y is 1. All right. And then since this is our range, we can say that it connects. That should be correct. Now watch me screw it up. All right, let's see how I did here. The book agrees. Finally. Good, good. Let's move on. See, learning from your mistakes. You remember things better when you screw up, believe me. And that's not me just saying that. That's a known fact. There was research, I can't quote the research, but I've read it somewhere that talked about how people tend to remember their mistakes more thoroughly than anything that they happen to get right. It's like, if you randomly get an answer right on a test, you're just going to forget it the next day. But if you screw it up and then you're forced to learn the correct answer, how it works, then you're going to be fine. Okay. Not draw a straight line to save my life. Okay. 17. The natural times the integers. Okay. So, gotta think about this for a minute. So, what can we say about the natural sets? And so, this is where, if you just go straight into graphing, it's a quick way to screw it up. We're gonna say naturals range, they don't use 0. Yeah, that's fine. So they go from 1 to infinity. Our range is, we go from 1 to infinity. And then actually we're going to say this way. We're going to say it this way. And just from 1 to infinity. So infinity, we're going to open brace like that. Now our integers. Zahlen, that's what the Z is. It's German. It means numbers. Okay. -3, -2, -1, 0, 1, 2. Also whole numbers. And so they range from -infinity to infinity. Okay. X, Y. All right. So if we're multiplying naturals time integers, then if we say A times B, so, or in this case, it's going to be X and Y. Probably simpler if we did that. Let's say X times Y. So we're making X, Y sets, right? So we know that the naturals are all going to be our X's, and then our Y's are going to be our integers. So for instance, let's just, we need to start putting numbers down. It'll be a little easier to graph once we do this. So let's see here. Let's go with X and Y. All right. So we're going to say that X, let's just organize them. 1, 2, 3, 4. Okay. That's pretty simple. And that goes on forever. So when X is 1, Y can be Well, let's see here. It could be, let's say, a -3, -2, 1, 0, 1, 2, 3, and then da, 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 da. It could be any one of those numbers. And then, but there's no intermediate numbers. In this case, let's see here. We can't have like half numbers. Now, something else the book gives us on page 10, if you downloaded it, it's free. It's in the description. This is going to help us a lot. I'm putting this out there because this is, in the 1.2 section, obviously there's reading material, and this is what it describes as an n by n chart. That's what an R2 would look like. So in this case, it's all positives. This is negative times negative. This is going to be, again, this is negatives and this is negatives. So what happens is we cannot, when this is going to be a negative times positive, this is negative times, this is positive times negative, and negative times negative. Okay, so, but this is positive times positive. Naturals can only be positive, and they cannot be either one. See, there's none on the 0 axis because they start at 1. So using that principle, how would we populate it? So we know that they can all be, let's just, right now, we're going to worry about graphing in a second. I'm just going to try to do it just by looking at it here, right? So we know that this is an X exists here, and this is positive, positive, positive. Yes, that's true. We agree with that. Now we're trying to do this. N times, okay. So positive and positive, yes? Okay, good. What about positive? This can be negative. So integers could be negative, so that's fine. The X, wait a minute. So, well, yeah, that's fine. That works because X is positive, Y is negative. X is positive, 1, Y is negative. So this is acceptable. This is fine. Okay, so that's fine. Now, we cannot go to this because even though Y is positive, X is going to be negative on this side. So we cannot be on that side, and we cannot go on the 0 axis because that wouldn't make our X be 0. And we can't do that because naturals start at 1. So this is really the answer. I think that 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3. Okay. So again, we're going naturals times integers. Natural is 1 times 1. So 1 and 1 right here. 1 and 2 here. 1 and 3 here. Okay, good. 1 and 0 here. 1 and 0, or 2, wait a minute here. 1, oh, 2 and 0. Yes. So this is the same down here. And then actually, when I was saying it, I explained it incorrectly, but I'm writing it correctly. X is 3, Y is 0. That's fine. Okay. X is 1, Y is minus 2. X is 2, Y is minus 1. X is 3, Y is minus 1. Okay. And here, and here, and here, and here, and here, here, and here, here, and here, and here, and here, and here. Okay. Now, what about the X equals 0? We can't do that. Even though the Y's are positives or negatives, we can't touch that because our naturals start at 1. I believe that's the answer right here. Let's take a look. 17. Yeah, the book agrees. All right, good. 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 Let's keep going. Now, like I said, they pretty much gave us the answer in figure 1.2 C, because it's just n times n, and then if you just took that principle and applied it further to n times z, or naturals times integers, then yeah, it's pretty straightforward. Yeah, not much to think about there, but it was still worth really going in depth about it. Okay, so those, if anyone is watching this, is who has seen the previous stream, then already knows that I answered this correctly in the previous stream. I jumped completely ahead from A to the last question, mostly because I wanted to see it in R3. It's been a while since I graphed in R3, and I got it correct, which I'm pretty happy about. Okay. Like I said, you got to enjoy this, right? We're here to have fun. Speaking of having fun, I'm going to do that question, but I want to look ahead for a second here. List. Okay, A is fine. We can blow through that. B. Oh, this will be fun. Okay. Yeah, I think we might even go through 1.3. It's very short. It only has A, B, and C, but it's only a couple of questions there. Yeah. And then power sets. Wow, I might be on a roll here tonight. I might just go nuts and just... Now, here's the thing. I would stop a stream and restart it just because, for video's sake, anyone watching afterwards. I don't like it 4-hour streams because it's impossible to figure out anything interesting. And it's tedious, takes forever to load on your phone. And I want to organize them by section, right? Every time I do a section, then we go continue. But getting back to 19. So what I'm saying is, I'll tell you if I stop the stream and I'll be restarting it. Sketch the Cartesian products on the xy plane. In this case, they want us in R3. But let's say we don't know that. I don't know that, right? I mean, we know that because they tell us, but what if we don't know that? So let's just leave that information off. We're going to figure that out on our own. Okay, right away, square braces. So we're going to be some kind of range here, right? This is going to be a closed range. Whatever we make is going to be a closed range. As a matter of fact, as a warm-up, we can do the first one real quick, right? Just the first two. What would this look like? It would be 0, 0, 0, 1, 1, 0, 1, 1. So 0, 0, 0, 1, 0, 1, and 1, 0. Here, yeah, this is 0, 1. This is 0, 0, yes, 0, 1. Oh, right here. Sorry, I messed it up. 1, 0, 1, 1. And it would look like this. So I'm kind of giving the answer away already, but basically right here, this is a range, and I did the math quickly, and I didn't even bother writing it out, but that's what it would look like if we just did in R2, and that would be the correct answer. So in R3, okay, so we're going to do A, B, C, okay? All right, order pairs. A1 times B1 times C1. When you have it like this, don't throw on extra parentheses. Just do what the thing's given you. I've made that mistake in a previous stream before, and I mentioned that. If you start throwing parentheses and doing A times B, and then do those, and you do A times C, you can get there's ways of getting the correct order, but the problem is by throwing parentheses, then it would affect the shape of it. So you would be wrong, but just for a different reason. So anyway, if they're not giving you extra parentheses, don't put them in there. Okay. A1, B1, 0, 0, C2. Okay. Now, we're going to say A. So the C is done. A1. No, A2 now. A2. B1. C1. Okay. A2. C2. Or B2. C1. Okay. No. No, that's incorrect. Jumping ahead, jumping way ahead. A2, B1, C2. That's better. And real quick, because it's a little complicated, we should quickly figure out the cardinality. It's the cardinality, right? So this is going to be 2 items times 2 times 2. So it's 2 times 2 times 2, which equals 2 to the third power, which is 8. 8. Or 2 times 2 times 2. Okay, so we know there's going to be 8 distinct things there. The reason I threw on the long lines here, the absolute value lines, they're used as cardinality markers or cardinality brackets. Cardinality means size. Okay. Let's see if it did this. Okay, that's good. So we got 4. We need 4 more. Okay. All right. Let's go with A2, B2, C1. No, yeah. Doesn't matter. Now, I might get the ordering of a modal off, and I'm going to have to go back and fix it, but that's fine. I'll be able to get this. Let's say A2, B2, C2. Okay, there's 2 missing because we need a cardinality of 8, and we got 6. So let's write some subscripts, and we'll figure out what's going on. A1, and then this is going to be B1, C1. Okay, this is going to be A1, comma, B1, comma, C2. A1, comma, no, A2. This is A2 now. A sub 2. That's how you properly read it. A sub 2, B sub 1, C sub 1. A sub 2, B sub 1, C sub 2. Okay. And then we're going to say here, okay, before I write this and make this any more confusing, I'm just going to see, I'm going to just stare at it and see if I can catch my mistake. Not mistake, but I'm missing 2. We got to figure out where I did this. Okay, I see right away. No, wait, hold on. Let me see here. A sub 2, B sub 2, C sub 1. A sub 2, B sub 2, C sub 2. Okay. No, hold on. Brain's not working now. Okay, just stare at it for a second. I'm just tired. I worked 14 hours yesterday doing a move for one of my clients. And before that, leaf cleaning this whole week. Just on 2 clients, I spent 40 hours, 2 different clients. And because I subcontract myself out with other landscapers, I do moving when necessary. I do all kinds of stuff. Like some people, they use me for a bunch of unrelated tasks. Anyway, doing good though. Hey, it's a living and I enjoy it. Every day is a new adventure. Speaking of, if you want to see my adventures, just go on Instagram, look up Ice Dancer Oleg. It's a lot different. It's not mathy. It's just photos I take of my everyday work and adventures. It's fun. Let's see here. A sub 1, B sub 1, C sub 1. A sub 1, B sub 1, C sub 2. A sub 1, B sub 1. Oh. Right. A sub 2, yeah. B sub 1, C sub 1. Okay. A sub 2. Where's A sub 2, B sub 2? Right here? Right. That's A sub 2, B sub 2, C sub 1, A sub 2, B sub 2, C sub 2. Oh, okay. Hold on. A sub 2, B sub 1, C sub 2. You have that. Okay. About, let me just do 0, 0, 0, 0, 0, 1, 0. Okay, so A is done. Except for 1 now. 1, 0, 0. Yes. 1, 0, 1. Yes. Next, it's going to be 0, 1, 0. That's it. I missed A sub 1, B sub 2. Okay. 0, 1, 0, 0, 1, 1. Now, the reason I was able to catch myself is because I checked the cardinality, right? So this stuff's important. I'm not just, making it up and make our lives more difficult. It's meant to keep us on the straight and narrow. Next thing I got to do is make sure I didn't do double work here. So A sub 1, B sub 2, C sub 1, A sub 1, B sub 2, C sub 2. B sub 2, C sub 2, and A sub 2. Not A sub 1. Good. And then, so this is good. Yeah. 0, 1. No. Good. All right. We are good to graph. Let's go wild here. Okay. Now, there's a couple ways to do this, right? And that wasn't it. So I'm going to show you a couple of ways we can do this. If we had negative numbers, we would graph like this. That would be our z-axis. This would be our x-axis. And then this would be our y-axis. All right, so that's one way to graph it. We can say x, y, z. And this is when you have positives and negatives. And also, this whole thing rotates. Just keep that in mind. You could do this. You can go like, this might be more visually appealing. C, X, Y. That might be more visually appealing, and that's probably the the one I'm going to use right now. Okay. Now, since we're all in the positives, right? Then I can just do this. I can use this kind of a form. So this is Z is positive. And then we're going to say Y is positive. And we're going to say X is positive. Okay, that form is not bad. Again, more visually appealing to me. It's about, see, you have to rotate things in 3 space. Now, we have to project a 3-dimensional object onto 2-dimensional space, which we do all the time, video games and stuff, but it's hard mentally just to do it on the fly like this without software. But it's good. You have to force yourself to do this. All right, now I'm gonna draw it a little bigger. Not much bigger because I don't have much more room here. Okay. X, Y. So it goes up top. It's X, Y, Z, like this. All right. So let's do it. Let's graph this. 0, 0, 0. By the way, these are closed points. And also, A will range from 0 to 1. B will range from 0 to 1. And C will range from 0 to 1. When we have the way we did it, closed ranges, these are not, if this was all in curly braces like this by themselves, if it was like this, those are just a list of items. But in this case, these are ranges. And the way we were able to map it, again, it's hard to see it just because they're all zeros and ones, but that also is an identity thing. You'll see that later on. It's IJK. I believe that's the order. It's for vector spaces. Vectors, it's done in 3 space. So that's calculus 3. And okay, that's another class I took but did not pass because I had to focus on work. Here we go. 0, 0, 1. So now in this case, X, Y, Z. That's our form that we're using. Okay. 0, 0, 0, 0. 0. We're going to say this is going to be 1. Say this is going to be 1. I'm going to say this is going to be 1. Okay. A0, B0, okay, Z is 1. So right here. Good. Next, we're going to say A is 0, 0, 1. Okay, X is 1. Y and Z is 0. So we have, actually not. Let's use a different color. Why are we tormenting ourselves? Here we go. You can hopefully see a little better. Yeah. Okay. Now, next we have a 1, 0, 1. So X is 1, Y is 1. No, X is 0, Y. So it's right here. X is 1, and then Z. So we have to project their space to here. These are my mental projections, okay? That's just all how you want to do it. So that's it. Give or take there, okay? Now, so then notice it's not in Y. In this case, it will be in the 0. It's just A and Z. Next, we have X is 1, or X or A is 1. B is 1. So we're going to say Z is 0. We are just trying to find this thing. Trying to make it work to where it's between them. Okay, something like that. Give or take. I want to leave a few of these marks just to kind of visually serve as cues. Okay, so we have, we have this, we have this, we have X is 1, yeah, we have this, then we have X is 1, Y is 1, is 0, good, 1, 1, 1, okay, so then we have X is 1, Y is 1, Z, this is the hardest one, oh boy. I'll come back to that one. Let's hop to the next one. X is 0, Y is 1, and Z is 0, and Y is 1, Z is 1. So go here. Good, we should try. And okay, so we got this, and we got this. Just the 1, 1, 1. Okay. So it has to project now from this point, because that's 1, 1, and 0, Z, and then this point, and this point, and this point. So it all just kind of coalesces onto trying to be equidistant from all of these points, the 1 spaces. We're trying to be equidistant, right? This is hard. Drawing in 3 space is very hard. Okay, but we did it. Now, what else can we say about it, right? Well, it's a box, clearly. However, we might not get the answer right if we don't do this part correctly. We just have to remember, we just got this, by the way. Good. So we have 1, 2, 3, 4, 5, 6, 7, 8 points. Perfect. Now, remember, this right here, these are all ranges. So what they're saying is these are closed ranges. So in other words, everything is going to be filled in. I'm just going to keep it a little bit separate from the dots to make it a little easier to remember what I'm filling in here. But essentially, this is all filled in like this. It's a solid box. Because I'm drawing on the screen, I'm trying to draw in a way that it's still visually readable as a box. But the whole thing, like if I just filled it in completely and then you wouldn't be able to see exactly what I'm saying. But there is all that white space. I'm just doing that for perspective. The reason I'm not like fully dumping it in there is I want you to be able to recognize it and kind of still see the points that we were working with, right? That part's important. So yeah, this is a filled in box. Yeah, there we go. Just want the slightest space there between them. Okay, hey, that's pretty good. Look at that. We did it. We made a box. All right, and check with the book. All right. Yeah. Yep. The book agrees. Yeah, it's a filled in box. So that's good. We got it. Good. All right. And they even did shading for perspective there. But yeah, essentially that's it. And that is the end for section 1.2. So that completes it. Now we are going to go to section 1.3. Okay. Subsets. Cool. This is going to be fun. A little less mentally taxing, a little different. But again, it's just to get you going. It'll pick up very quickly. So I'm going to stop the stream and then I will restart it because I want it as a clean video. And yeah, we're just going to keep on rolling. Let's keep on rolling. Okay. I'm hoping everyone's enjoying this.